Good morning, good afternoon. Just going to give everyone a couple minutes to join. We'll start in about 2 minutes. Good morning, good afternoon. Good morning. Just going to give it another minute. All right. Okay, hello everyone. Welcome to this week's first session of the Foundational Training Series. We will be focusing on data engineering with Databricks today. My name is Nadia El Sayed. I am based in New Jersey, and I'm the User Success Program Manager at Databricks. Before we dive into the good stuff, let's cover some important housekeeping items. First off, this session will be recorded and the notebooks will be shared by the end of this week. Second, please use the Q&A function to ask our team any questions during the session. We will not be using and monitoring the chat function. Instead, we will be using the Q&A function. We will do our best to answer them in the Q&A section. Let me reiterate, not using the chat function. We have hundreds of students online today, so please understand that we may not be able to address all questions. If you have any unanswered questions from the session, please feel free to reach out to your Databricks account team who'll be able to help you in a closer manner. Workspaces are provided and available during class time today until 1:30 p.m. Pacific time and 9:30 p.m. GMT. All right. After attending the session, we will be providing you with a 75% certification voucher. That is worth about $150 to take on any of the 7 main Databricks certifications. We will be providing you with the voucher if you have completed the Databricks Lakehouse Fundamentals Accreditation version 2. This just came out last month. This is an update of our Lakehouse Fundamentals accreditation. This is version 2. Please complete it by December 22nd, as well as a session survey with your name, the email address you passed the accreditation with, and proof of the completion. If you're using a different email address between attending the session and completing the accreditation, please indicate both email addresses in the feedback survey. To clarify, the accreditation is an assessment that will provide you with a high-level overview of the Databricks platform. This accreditation targets the specific needs of platform administrators. You should expect to receive your certification voucher by mid-January. The voucher will be valid until June 1st of next year. Before I hand the time over to our instructor for the day, I'd like to share that you can continue your learning journey at Databricks Academy. Log in and continue your Databricks enablement on Delta Lake, Databricks SQL, MLflow, and more. Be sure to check out our full list of courses in the Academy. Last but not least, don't forget to complete the survey. And most importantly, enjoy this training. Without further ado, I am pleased to introduce your today, Mohan Matthews.
Thank you, Nadia. Can you hear me?
Yes, we can hear you.
Awesome, thank you. Thank you everybody for joining the session today. Really excited to have such a large group. I still see the participant count going up. But we have only 2.5 hours today and we have a lot of content to cover. So we will get started right away. And if you run into any issues with logging onto your workspace or any other technical challenges, please post that on the Q&A, and our TAs will be happy to help you out with that. Let me share my screen so you can see my slide deck. So hopefully you can see my slide.
Yes, we can see it.
Awesome, thank you. So super excited once again to have everybody here. I just wanted to take a minute to explain sort of the structure for today's session, right? We have 2.5 hours. We'll try to keep it very slide light because we want you to spend as much time as possible on the hands-on exercises. So I'll be sort of breezing through the slides. As you see the slides, if you have questions, please post it on the Q&A and we'll get to it during the course of the session, right? Okay, what are we going to cover today? So there's 3 things that we want to hit on so that you can understand these concepts by the end of the session. The first is this term you may have heard called the lakehouse. Databricks, has been talking about it for quite a while, but you've probably heard of it from other vendors and cloud providers. So let's give you an overview of what the lakehouse means. We'll then talk about Delta, which is, obviously a technology that Databricks invented and then open sourced. So we'll talk in detail about Delta and do hands-on exercises with Delta. And then we'll talk about Delta Live Tables, which is sort of our opinionated way on how you should build data pipelines going forward. And that'll also be a hands-on section. So overview of the lakehouse and then 2 hands-on sections about Delta and Delta Live Tables. So each of those hands-on sections I expect to take about an hour each, and that will give us enough time to fill in Q&A and other issues that might come up during the session. Okay, so like I said, we'll get hands-on with Delta and we'll build a pipeline, and you should be able to confidently do this by the end of this session. But before that, let me introduce myself. I am Mohan Matthews. I'm a senior customer success engineer here at Databricks. There's a bunch of stats written about me there that you can read through, but I've been working in the industry for a while, and with a background in like many different facets as mentioned there. The important thing that I wanted to call attention to is basically this data engineering V2 and V3, right? So the content we are covering today is part of the data engineering persona and pathway in the Databricks Academy. And if you go to the web assessor link and try to register for a certification, you will see there are 2 options. There's a V2 of the certification and a V3 of the certification. And there are slight differences in both. Because V3 has some of the later technologies such as Unity Catalog that we introduced, which V2 doesn't have. But the content that we are covering today with Delta and Delta Live Tables is applicable to both. So you should be able to confidently answer those sections of the certification exam with this content for at least those 2 sections. And I just took the V3 exam last week, and I hope a lot of you can get certified in the near future. Awesome. So let's kick off, right? What is the Databricks Lakehouse platform, right? It's one simple platform to unify all of your data, analytics, and AI workloads. This sounds simple. Why isn't everybody else doing it? Well, it's not that simple to actually implement and adopt, right? We want to make it simple, and we think our platform is the easiest way for you to adopt this architectural paradigm, right? As you've probably heard many times, Databricks has 7,000 customers across the globe, and we are the original creators of open source technologies such as Spark, Delta Lake, and MLflow, and a few others that we will touch upon a little bit later. And there may be other technologies that you think are proprietary to Databricks today that may become open source in the future, right? So because we are founded on open source, we'll sort of keep pushing the envelope there. What is the Lakehouse trying to solve, right? So most enterprises struggle with data, right? You may have heard data is the new oil. I'm not a particular fan of that statement because oil is still concentrated in the hands of a few powerful countries. But data is of the most value, I would say, to organizations, right? It's the most valuable asset you have, your data. But enterprises struggle with it, right? As you can see in the slide deck here, you typically have all of these silos that are most probably internally defined silos of personas and data sets, right? So somebody will decide this particular data set belongs in a data warehouse, and somebody else will decide this particular set is not required for a data warehouse. So you'll run into all of these organizational challenges, and then you will have to figure out how to actually stitch all of this together. So in this example here, if I was doing machine learning, how do I get access to all of the data in my data lake for machine learning, right? I have to come all the way back here to the data lake to get it. right? And then let's say there was a use case in which I wanted to join some curated data that's sitting in the warehouse with something in the lake. How do I do it? It's a problem because most likely you have to pull data out of one system and push it into another system. And the Lakehouse platform, we believe that all these walls should not exist, right? So again, to reiterate, is one platform to unify all of your data analytics and AI workloads. And why do we need this platform? We'll cover that in the next slide. But the foundational technology that we believe enables this platform is Delta Lake, right? So Delta Lake is an open protocol built on top of open source Parquet, right? When we talk about storage formats, you may have heard Delta referred to as a storage format. I don't particularly like that terminology because the storage format is still Parquet, right? Just like ORC, Parquet, CSV, all of these other formats you heard of, we're not changing anything with Parquet. Parquet is Parquet and it's open source and it's the most heavily used open source format out there. What is Delta done is add a layer of a protocol on top of Parquet to guarantee that any writes to Parquet as files can be registered back to the metastore to say that this is the source of truth, right? So even if I write a half attempted file, it shouldn't matter because my transaction log is keeping track of the accuracy of the table itself. So as long as the table is accurate, it doesn't matter if I write a bunch of junk files. So Delta bridges that gap and makes Parquet really behave like you would expect a table in an RDBMS. And obviously, we've built so many performance knobs into Delta on top of Parquet that gives you the reliability and the performance. So again, it's not a format in the way that you typically think of a format. It's still Parquet, but it's called a Delta table because Delta adds a layer of performance and reliability on top of Parquet. So we've talked about this a few times, but the main things to think about when you think about when the Lakehouse platform is it's simple, right? We want all personas to have a very simple experience in dealing with the data that they want to work on, and also the activities that they want to work on. Whether you're a machine learning engineer or a data engineer or a SQL analyst, we want you all to have a simple experience in one platform, and that's the Databricks Lakehouse platform. It's obviously open because a lot of the technologies that Databricks has sort of pioneered is in open source, and we'll continue to keep doing that as we push the boundaries. And it's collaborative, right? So I could have a notebook as a data engineer that I wrote that I can share with an ML engineer, I can share with a SQL analyst. A SQL analyst could have a SQL query that he wrote in Databricks SQL that he can then share with a data engineer or machine learning. So all of us are in the one house and we're sharing the same assets, which is very difficult to do if you have different tool sets for different personas. So simple, because you can unify all of your data analytics and AI on one common platform. Open, because obviously we have some of the most successful open source projects. You can even see Koalas and Redash mentioned here. Redash is a company we acquired and then built into Databricks SQL. And Koalas was already integrated into Apache Spark. So you can just refer to it as PySpark.pandas now. So again, we're continuing this motion of being open. And no one company can do everything, right? So any vendor that tells you they can do everything is not being truthful. We can help you do everything with our partners, right? We're giving you one platform that you can do everything in, but for everything that is not natively built into, or that partners are really specialized in doing something, we integrate with all of those partners. And that integration is worked on by engineering teams from both sides, so it's a very smooth integration. And collaborative. I think my slide here got a little messed up, but like I said, all three personas can work on the same data and the same assets at the same time. Right? Okay, that was your introduction to the Lakehouse, and you can read about this on our docs as well, and we have published various papers on the Lakehouse, which is I would say good reading to catch up on all the latest on that. But what is Delta Lake, right? So Delta Lake is an open source project that enables building the Lakehouse, right, on top of existing storage systems. So your storage system is still your cloud storage location. It may be an S3 bucket, it may be an ADLS container, it may be a GCS storage location, but it's your bucket. You own the data, right? You never write the data into Databricks storage. It's always your bucket. and you're writing it out in open formats, hopefully in Parquet or or Avro today. And our suggestion to you is if you're already doing that, you should take the next step and just write it out as Delta, right? Because you're going to get a performant layer on top of Parquet and get rid of a lot of problems that traditional open source systems storage formats have. So to reiterate, it is not a proprietary technology. It was open source from the very beginning, but in Summit of 2022, we open sourced all of Delta with a new release called Delta 2.0. So there were some knobs that Databricks had kept proprietary, but those are no longer proprietary. That's also been open sourced. So you could, download open source Delta and take it for a spin today, and it would work pretty much identically to how it would work in Databricks, right? Now, your next question will be like, why would I use Databricks? I'll get to that. But it's not a storage format, right? It's not a storage medium because the storage medium is still your object storage. And it's not a database service or a data warehouse because a data warehouse typically means that you ingest data into a closed system, right? That is built for purpose. But that's not the case with Delta. It's just you're writing your Parquet files out on object storage. So it is open source. It builds upon those standard data sources, right? So it's still using Parquet with this transaction layer on top. And it can be run anywhere pretty much, but optimized for cloud storage. And it's built for scalable metadata handling. What does this mean? This means that traditionally in, like if you look back at the Hadoop world, as your data grew, your metadata grew as well. Right? And then handling the metadata, that is, what are the files that make up a table in Hadoop was eventually become exponentially more expensive as you try to traverse the tree. But that's not the case in Delta because Delta has a cool trick on how it maintains the transaction log and how it keeps track of the commits that need to go into the transaction log, right? So we have something called a checkpoint. So every 10 commits, and AWS actually we changed it to 100 commits, we'll make a checkpoint, and that checkpoint is JSON, and that's we basically can put it into the memory of the cluster and refer to that checkpoint. So every time 10 or 100 more commits come, we'll just update the checkpoint, and the cluster always has the latest version of the table that it can refer to. You never have to do like refresh table again, which is a concept that if you're familiar with other Spark systems or even on Databricks, if you're using Parquet or CSV, most likely your table goes out of stale, and then you have to do a refresh table. That's something that you don't have to do with Delta, because in Delta, the metadata and the data are stored together on cloud storage. So we'll always pull the latest one, put it in memory, and if there's a new commit, that checkpoint in memory is updated. So you don't have to worry about that kind of management anymore. And most importantly, it brings ACID to object storage, right? So what is ACID? These are 4 properties that traditional RDBMS systems have always had, which was really the power of the data warehouse. Data lakes never had this, right? So atomic means that all transactions either succeed or fail, right? You cannot have an in-between option where half of it partially succeeded and then I don't know like what my table state is. Consistent means multiple readers should get the same view of the data, right? If I execute a read from here and I read from another cluster, I should get the same view of the data. So it's consistent. Isolation means if I have multiple operations writing to a table, can I guarantee isolation, right? So in most cases, you'll hear database systems talk about serializable and snapshot isolation, things like that. But essentially, how can you ensure that multiple transactions are happening on the table without them conflicting against each other? And that's what Delta guarantees. And the 4th thing is durability, which means the changes are permanent, right? Nothing can happen once you make a commit. You're guaranteeing that that table, once that commit is done, that table version is stable till the next commit happens. So why do we need this, right? We obviously don't need it if there are no problems in real life, but there are problems in real life. So it is very, very difficult to do updates and deletes in the Delta in data lakes in general, because you have to rewrite large files. Imagine you have like a large table with hundreds of gigabytes of files floating around, and you want to update one row in that table. It's like looking for a needle in a haystack, right? It's a very difficult problem to solve, and Delta solves this with a few cool tricks like data skipping and inbuilt merge, which happens in one transaction. you will never have a problem of a transaction or a job failing midway. Because even if it fails and we wrote out Parquet files, we have not registered those Parquet files in the transaction log. So as far as the reader is concerned, and as far as the table itself is concerned, the table is never corrupted, right? So when you restart your job, we're going to rewrite those Parquet files till you get a successful commit, and then your table is in a clean state anyway. You can unify batch and streaming operations with Delta, right? Delta is can be both a source and a sink for both batch and streaming operations. So you can sort of unify your architecture and adopt one common architecture. And we'll talk about this a little bit when we get to the Delta live table section. And Delta also allows you to travel back to a version of your table. So let's say I wrote version 1 today and I wrote version 2 tomorrow. If I wanted to query version 1, this is not possible in a traditional sort of data lake table, right? If you had written it out in Parquet or ORC, or it's not possible. We allow that because we can travel back through the transaction log because it keeps a record of each file that was written that is related to that transaction. So that's something that that Delta allows you to do, right? And it's, again, this is not the way to just keep historical snapshots in like for perpetuity, but it's a way for you to sort of roll back to a version that is good for a limited period of time. Awesome. So just to reiterate, it's open source. The data is in your cloud storage, right? It's Parquet with some additional files thrown in for the transaction log. And there's no lock-in. You can easily convert back to Parquet. Tomorrow you don't like Delta, you can go back to Parquet. We even have a clone to Parquet command now, which allows you to not even convert directly from Parquet to Delta. You can just create a copy of your Parquet table in Delta and then work on that as a POC, for example, right? Before you adopt Delta fully, which is a really cool thing to have. How does it look on cloud storage? It looks something like this. So you'll see there are a bunch of Parquet files and there's a Delta log. So that's the only really real difference. All of these Parquet files would have been the same Parquet files that you wrote if you had kept the table format as Parquet, but we add something called a Delta log that really is the Delta transaction protocol implemented, right? Which keeps a track of all of these Parquet files. Awesome. So that was, I was as fast as I could get through those slides, and we'll not waste any further time, and we will jump to our workspace. Okay, so let's see if, I don't know if I see a few questions, but I think the TAs will handle that. So we'll start. If you're in your workspace, I encourage you to go to click on workspace and click on your user. Like you can click on home right here to get back to your user. And my username here is ODL_instructor. And it'll show me this folder, which has the data engineering learning pathway, right? And if you click on that, you'll see this big long list of folders. Obviously, we're not going to have time to cover this entire content today in 2 hours. So we're going to focus on sections 3 and sections 4, right? So if you could navigate your way, just click on the home folder and then find the data engineering learning pathway, and then click on O3 Delta Lake, and you'll see all of these. And we can actually skip 3.1 and go straight to 3.2. So we'll start at 3.2 and click 3.2, and you should see this specific notebook. And I'll just pause for a section to see if attendees have been able to get in there. I think it's just normal Q&A, so I'll keep going. So what we want to do is we're going to be doing sections 3.2, 3.4, and 3.5 in today's session, and then we'll take a short break, and then we'll go to Delta Live tables and do some of the sections there. So let's start with 3.2. So if you're in this notebook, and I hope you are, you can go ahead and run your classroom setup. And when you try to run it, you might be prompted to attach to a cluster. Now, I am already attached to a cluster here, lab cluster. You all should have your own clusters. I'll show you what it looks like from an admin view. You will not be able to see this, but there will be several clusters like this that have been spun up for each of you. So each of you will be able to have access to one of these clusters. And when you try to run this, you should see a pop-up. Let me actually detach from this to show you what it looks like. So now I am detached from the cluster. And if you ever want to connect to a cluster, you just click on the connect here and you can connect to any cluster that you have access to. But if you don't want to do that, you can just try to run the cell by clicking this arrow right at the right corner here and say run cell, right? And when you say run cell, it will prompt you to attach to a cluster. Now, in my case, it says automatically connected to the notebook's last used compute. If you have never attached to a cluster, it will prompt you for the cluster to which you should attach, and then run that button. If you're not super familiar with the notebook interface itself, we won't be spending a lot of time on that, but it's pretty simple. Each cell you can run by clicking this little run button here and say run cell, or you can do a shift enter or command enter depending on your keyboard. I have a Mac, so I do shift enter and that'll run a cell too. Awesome. So while that's running, let's talk about what we are going to talk about in this session, right? So like we said, Delta is just basically writing out Parquet files on this. What we are going to talk about in this session is essentially what are the performance benefits that Delta is going to give you on top of open source Parquet, right? So we'll cover this concept of optimize. Again, if you've been working in sort of the lake, in data lakes in general, or in the big data system, in the Hadoop system, you're familiar with what is generally referred to as the small files problem. And the small files problem is multiple writers, your data engineering pipelines could be writing files of various, differing sizes. Everything starting from like 1 MB all the way to like, maybe 500 MB, right? Depending on how you configured your Hadoop clusters in the past, you could be writing files that are really big or small, and there's like these varying file sizes. And opening files, essentially in cloud storage, is an expensive operation. Like basically traversing the list of files to open and opening files is an expensive operation. So when we lay out files in a consistent manner in terms of size, it helps with that operation. But only when you additionally have some intelligence built into your engine to say which files to open, which is where Delta comes in, right? So when you have a predicate that says, let's say customer ID equals 1, if you have some intelligence built on top of the Parquet that says, oh, for customer ID equals 1, I don't need to go look at these million files. I know I can only go and look at this file. How do we know that? That's because we collect statistics on all numeric and string columns that are in the first 32 columns of your table, right? And you can reorder these columns the way you see fit, but by default, we collect statistics for the first 32. And the statistics are like min, max, mean. So that allows us to essentially skip a file without having to open the file, because the transaction metadata is telling us that you can skip a file, right? And we'll talk about some of these other points mentioned here as well. Okay, so I hope most of you have been able to run command 4. So what it does is essentially it prepares data for you. There's a few data sets that are mounted. So you can see here that it is a data engineer learning path. It's the same reference you will get when you go to our academy. We'll point you to this so that you can clone this repo and mount these data sets as needed. And you'll also see a working directory and a user database. So the working directory is unique to you. So you can see my instructor name here, and what you'll see is your username, right? And all this happens behind the scene with some of the helper files that are in this include section. And so this is the working directory, and this is the database that is created. And if you want to actually see this database, you can click on the data section and you can see this database. So I think I created a few because when I was rehearsing for this. So this is just learning path. So I think it's this one. So I've not created any tables. I've just created a database, right? Awesome. So what are we going to do? We're going to create a Delta table and study its history, right? One thing I want you to understand as you run through this exercise is this running all of these commands in this one cell is equivalent to you running each of these commands, like create table in one cell and then the insert in another cell. They're exactly the same. In terms of the way the engine operates, each of these is a separate transaction. So the create table is going to be the first transaction. So, and delta is 0 indexed, which means the first commit of the table will be version 0. And then this insert will be transaction 1. And then this next insert will be transaction 2. So it keeps going that way, right? Now, this is a very simplistic exercise, but in your case, in real world scenarios, you probably have an insert that puts in 1,000,000 records. So all of those 1,000,000 records are going to get committed into one transaction, right? Not like one row at a time like this. But this is just to illustrate the example. So if we run this cell, and if you pay attention to this running command here, you'll see some interesting sort of messages about table creation and versions and things like that. So you'll see some Spark jogs have been launched. It says compute snapshot for version 0. So it's figuring out, oh, this is the version 0 of the table. And it's running a few more commands because it has to do all of these commands to bring the table up to state where we want it to be. So you'll see it's sort of cycling through version 1, version 2, etc. like that. It says finding files to rewrite. Why do you have to rewrite? Because we're doing a merge, right? We're doing an update. If you do an update or a merge or anything like that, that means we have to rewrite files. If it's just an insert, you don't need to rewrite files. You just write new Parquet files. And the log says, oh, a new Parquet file was written. But when you have to do a merge, you're rewriting files. And by rewriting files, it's not the same Parquet file that's rewritten. It's another Parquet file that's written, but it's a new version of that file, right? Meaning like something changed. So I did an update and you can't update a Parquet file in place. Parquet doesn't allow it. So you have to write a new Parquet. But Delta keeps track of the fact that it wrote a new Parquet. So the output you see here is only for the last statement, which was this merge. And let's just spend a few moments looking at what it means, right? So obviously you can insert one row at a time. So insert into students' values, which is typical like SQL syntax if you're familiar with it. All of this is possible in PySpark as well, or Scala if you wish. Or you can insert multiple rows at the same time. So the difference between rows 4, 5, and 6 is that each of these is a transaction. This is 3 transactions. But this one, because we're inserting 3 rows in one transaction, is just one transaction, right? So just remember that each transaction is like whatever you give to that specific command. And then we did an update. So this would be another transaction. And then we did a delete. Now, if you're familiar with other open source technologies, it's almost impossible to do a delete because you can, but you will have to rewrite an entire file. So if you have a 1 GB file and you deleted one row, you have to rewrite that entire 1 GB file, right? Because you deleted one row. So we want to make improvements here. We have some other cool things in the works that is going to make this even faster. But it already works. It just keeps a track of which file had to be removed from the transaction log. This is another way in which you can prepare your data sets to insert into a target table, right? So think about a simple scenario where you say update table, X, where ID equals 1. Right? Okay, this is easy. There's one table and there's a predicate for one row or something. That's easy. But now you have a data set like a lookup table or a reference data set or something that you want to actually update that whole data set into your target table. So how do you do that? You do that with merge. Merge is essentially Databricks' implementation of an update plus insert plus delete. You can do all 3 in one operation. In other systems, you may have heard of this as upsert. An upsert is an update and insert. So merge just takes as a way like one step further and says, oh, within a merge, which is one transaction, you can do all of these operations at the same time. You can do an update, an insert, or a delete, right? So you can do all of this in merge. In this case, we are not, actually we are. You can see here that when it's matched and when the incoming source type satisfies a certain condition, we're actually deleting the row itself, right? So you can do an insert, as you can see here, a delete, and an update all in the same transaction, which is a really, really cool thing to have. The advantage of doing it this way is that you will not have a corrupted version of the table. Because if this transaction fails at any point, your table is still pointing to the previous version that you finished here. Whatever was the table that finished at that version, that's still clean. All of your readers reading that table are still getting clean data. They will never see sort of on the fly written data. okay, which is the good thing about the sort of the transaction protocol. Each transaction, and that's how we guarantee ACID. Basically, like all of these happen in it's an atomic transaction. Awesome. Now that we created that table, so this is the table students. If you want to inspect something about that table, you would examine it. There are a few other commands like describe detail. To see here, there's a describe formatted. There's a few different ways in which you can describe, but let's start with the simple one, which is describe extended, and just run that command. And it will tell you the schema of the table. So in this case, our ID, our name and value, which we defined up here as int, string, and double. So you can see that up here, int, string, and double. Spark catalog here just means it's your default metastore, right? So when you spin up a Databricks workspace, you're either using a Databricks internal metastore, or your admin has set up the cluster to point to an external metastore, Hive-based metastore. It could be an RDS, it could be Azure SQL, or anything like that. Whatever that is will show up here as Spark catalog. Spark catalog just means default metastore in the context of this command. It's telling you which database I wrote to, and it's giving me this interesting information about the table being managed. Yep,
Mohan,
go ahead.
sorry to interrupt. Is it possible for you to zoom in a bit the browser window, the browser? So some people are complaining that they cannot. A bit bigger, yes, please.
Is that better?
Thank you. Yeah, I think yeah, that's all. Yeah. Thank you.
Okay, awesome. Thank you for that. Let me see if I can make it even bigger, and let me get rid of this pin. So that should be better. Okay, cool. So we haven't touched on managed and external tables before, but let me take a minute to explain it. A managed table in the context of Databricks is a table in which the data is, if you delete the table of a managed table, you are deleting that table from the metastore, but also deleting the contents, the actual files that are made up in that table from your cloud storage, right? So a managed table essentially means a drop table is a destructive action, like meaning like I want to clean up my files that are on cloud storage as well. An external table, on the other hand, if you drop an external table, you'll only drop the pointer from the metastore, but the actual files on cloud storage continue to exist. There is a notebook here that actually talks more about it, which is 3.1. I didn't cover it because it would have taken a large chunk of our session. But when you get the time, please explore this 3.1 notebook on your own. It'll give you a much better understanding of managed tables and external tables. But just understand that if you drop a table, a managed table, you're going to drop the data as well on cloud storage. And if you drop the table of an external table, you will not drop the data in cloud storage, right? We are not really going to talk about like Unity Catalog a lot here, but you may have heard about it. Unity Catalog has like another sort of trick on how you can restore that table, even if you drop a managed table, but it's sort of outside the scope of this session. But just understand in typical scenarios, when you drop a table, the data is gone from cloud storage as well. Okay, so if you scroll down here a little bit, it'll say provide a delta. Now, you'll notice I never gave a data format, right? I just said create table. I didn't say create table students using delta because I don't have to. Since about DBR, Databricks Runtime 8.3, delta is the default format, which means delta was mature enough and we had enough customers using it for production workloads on like petabyte scale that we realized that customers are running into a lot of issues by not using delta, right? We get lots of support tickets with like Parquet or ORC and like, you know, data being deleted or a table being corrupted, all of these kind of tickets. And so we just made delta the default. So if you are a really, if you have a real valid use case to still keep writing Parquet, no problem. You would say create table students using Parquet. That's it. And you write a Parquet table. But if you don't provide the using, or in PySpark, if you say .write format, then it's delta by default, right? So Databricks has made delta the default, which is why you see that here it's provider's delta. If I had said using Parquet, you would see the provider as being Parquet. Don't worry too much about the root. the table, because the tables are written out as the sort of root user that Databricks runs as, it says root, but the table owner itself is, if you do like a grant on this and you see the owner will be the person who created, right? But over here, it is show root. And is managed location is true because we wrote to a managed location. We didn't write to an external location on another bucket. We wrote it to the default sort of warehouse location that comes with Databricks. And again, this is explained in that 3.1 a little bit if you get time to look at it. Reader version and writer version, you don't need to worry too much about it. Just remember that there will be features that are added to Delta's protocol in later versions that you may want to take advantage of. And once you go to an earlier, sort of a later writer version, you can't backtrack. You're always at that sort of latest writer version. So you can set this as a config when you write the job itself, but otherwise it will just take the default of whatever the runtime is. And in my case, I think I'm using 11.3 runtime. So in 11.3, this is still the default. The mint reader version is 1 and the mint writer version is 2. Typically, you don't have to worry about this. Just go with the default on the runtime, unless there's a specific feature that you know you are waiting for. And then you can look at the docs and see, oh, which writer version is supported for that specific feature. And then you can upgrade the table to that writer version. Okay, so now there's another command called describe detailed students. And let's see what this does. It gives you slightly different information. It gives you the full sort of fully qualified name of this table. Again, Spark catalog just means hide meta store. And this is the database name, this is the table name. It tells you where it is stored. So this is the default sort of mount point that we created for this exercise, and it's stored in your specific folder, right? So your table will be stored in your specific folder. It's going to give you a created, a last modified, and it's also going to tell you the size of the table, right? An estimation of the size of the table. How big is it in bytes, and how many files are part of this table? And again, the same things of min reader and min writer. So different ways in which you can explore your table. Describe extended is one, describe detail is another. Okay, so when you think of a table in a traditional RDBMS system, you're not really thinking about where the data is stored, right? But in a data lake, you have to, because you're trying to bridge this world between data lakes and warehouses to create this lakehouse category. So a table is essentially still a list of files stored in cloud storage. And you can go and inspect it, right? So giving you this location, right? So you can take that location and we can do what is this utility function called dbutils that I can run to see what are the files that are made up in this table. And just like we saw in that last slide that I presented, there's a bunch of Parquet files and a delta log, right? And you can further inspect this delta log by just saying, okay, show me the delta log. I want to see what's in the delta log, right? So if I run this cell, it will give me some information about the actual files that are written. Now, these JSON files correspond to table versions. So this 000.json is essentially the create table statement. And then the 1.json is essentially that first insert statement that we wrote. Insert into table when you just gave like one row, right? So each of these are table versions. So now you can see there are 7 versions, right? Starting from 0 to 7, so 8 versions. CRC, you don't need to worry about. It's just like for the system to ensure integrity of the transaction as it writes it. And these are just optimization files that are required to maintain, like basically on AWS, we have something called a commit service that maintains the integrity of the transaction to ensure that the files written to object storage are actually have been written out, right? Because object storage in some cases, as you may know, is like eventually consistent. So we want to get past that. So that's why you see that. So you don't need to worry about that. So anyway, you can inspect these files. You can open each of these JSON files if you want to and look at the content. It'll basically give you the Parquet files that it is referencing. Okay, so this is the same statement that we wrote earlier, which is telling you the number of files and the size in bytes. But notice over here, if you scroll up here, there are way more files, right? There's like so many, 1, 2, 3, 4, 5, 6. and more. 7, 8, 9, probably 9 files here. Actually 8 files here. But our table version is only telling us there are 4 files. How come, right? Well, this is the beauty of it, right? You don't need to worry about how many other Parquet files are written, because those Parquet files refer to the older table versions. So in version 1, I wrote a Parquet file. In version 2, I did an insert that wrote another Parquet file. And then in version 3, I wrote a, let's say, an update that updated one of these rows that was in the Parquet file. Well, technically, even though I wrote 3 rows, 3 Parquet files, I only need to worry about 2, because one of these Parquet files is just an update of an existing Parquet file because the transaction was updated. So, which is why you might, sorry, you will see more Parquet files on disk than is actually needed to replay the version of the table. So the latest version of the table is what you'll see when you say describe detail. It'll tell you that 4 files are required, and which is what is explained, right? Rather than overriding or immediately deleting the files, we use the transaction log to indicate whether that file is, we should read it or not, right? And if you inspect this specific JSON file, which is the last file that we wrote, it will give you some interesting information that says, okay, I'm going to remove these files. This C00, 534, I'm going to remove that, and 647, I'm going to remove. What does it remove? It's not removing it from cloud storage. It's just removing it from that commit of in the transaction. See, when you query version 7 of this table, I do not need to read these files. That's all it's saying. The files are still on object storage till you decide to clean them up. And you can, sort of automate this with, doing vacuum and stuff. But when a new table version is written, all of those files are not destroyed. They're still there, which is why you are able to travel back in time to versions of elder tables, right? I can see here there were 2 files added, and there's some commit info here that says what we did, right? We did an insert, we did a delete. So all of these things, 2 files were added, 2 files were removed. So this is the information that is stored in the JSON, and the engine reads the JSON to figure out what files to go read to give you a consistent version of the data. Awesome. Let's keep going. Okay, so this is a simplistic example where we don't have a lot of data. But if you had like a really large, a terabyte worth of data, and you're doing lots of updates and inserts all day long, you're going to end up with a lot of small files. And you can control the size of the files that have been written. There are a couple of configs that you can say, okay, I want to write only 128 MB files, for example. But still, there's a chance that you will end up with files of different sizes. So what does Optimize do? Optimize essentially wants to get rid of your small files. By default, Optimize will try to create a 1 GB file by essentially rewriting a bunch of Parquet files into another Parquet file, which is 1 GB roughly. And you can tweak the size of that configuration as well. So let's run this and see what happens when Optimize runs. And when you do Optimize, you can also Z-order. And Z-order is, you're co-locating data elements within a file. So think about it like this. If I have a large file and I have, customer ID 1, 2, 3, 4, 5, and then I have a customer ID 999. I want to co-locate all the customer ID 1 rows in Parquet in a similar place, so that when I go look for it, when I open the file, I don't need to read the entire file. Even though I need to open the file, I know that if the rows are co-located, then I don't need to go past a certain point to give you back the result for that predicate, right? So that's what Z-order does. Z-order essentially is like a space filling curve that optimizes the way the data is laid out in each file, and Optimize rewrites the entire file to make bigger file sizes. So instead of having 4 Parquet files, I want to have 1 Parquet file. And you can see this when we ran this, it says num files removed 4 and num files added 1, which means I wrote a new Parquet file and removed 4 Parquet files. Again, I didn't physically remove it. I just removed it from the transaction log. And now this Optimize actually created a new version of the table. So if we go back and do actually below here, describe history, you'll see 8 versions of the table, right? Here, describe history. Earlier we saw that there was a 007.json. Well, now if you go back and query that original cell, you'll see a 008.json, which corresponds to this one. And what did it do? It optimized, right? So that JSON will say, okay, I just have one Parquet file to read. So if you were to do select star from table, I just need to read the Parquet file referred in this one. If I do select star from students version as of, which is how we talk about time travel, which is like how you could travel back to a version of the table, it is going to read this one, version 3. And what happened in version 3? How do I have only 3 rows? Well, let's go back to our original cell and see what happened. Like I said, this was version 0, this was version 1, this was version 2, this was version 3. So at the end of version 3, there should have been 3 rows, these 3 rows. And that's what we see when we query version 3, right? So this is basically how like time travel works, right? You can always go back to a version that you wrote in the past, as long as those data files have not been cleaned up, which you can choose to do based on certain duration, and as long as you have not done any other changes to the table itself outside of Delta, right? Always operate with it in the same fashion. Like don't try to write to it from like outside of data, not outside of data, but always use the Delta protocol to write to a Delta. Okay, now let's say I'm a user and I by mistake deleted this. So this is essentially the equivalent of doing truncate. So if I say delete from students, you'll get num affected -1. -1 is just our way of telling you that the table is empty. It might be confusing, but that's what it is. So now if you try to query this table, you'll get nothing back, right? No results, because I deleted everything. But I know I have a clean version, this one, version 8. So I can go back to it. So what we'll do now is restore the table to that version by running this. And it's going to give you a statistic of what it did. Now, when we say restore, we are going to write a new version, a clean version, but based on the version 8. So it's going to be a new version based on version 8. So it says, okay, number of files after restore 1. Why is it 1? Because when we did optimize and created version 8, we were left with just one large Parquet file. So we could just take that file and we don't have to rewrite the file, but version 10 just points to that same Parquet file. And that's all you need to do. So you don't really need to like rewrite that Parquet file. It's just a pointer in the JSON. Awesome. So now you may have heard of this statement called vacuum, right? So we wrote many versions, and you might think, okay, I have, after a month, I have tons of versions and tons of Parquet files sitting out there. Why do I bother with it? I want to clean up the old stuff. And you can set it up to say, okay, I want to vacuum all my data out, the actual Parquet files from cloud storage out every 7 days or every 30 days, whatever you choose that to be. You can even do 0. So if you do 0, that means I only want to keep the latest version of the table and the files associated with the latest version of the table. I will go and get rid of everything else, which means I cannot time travel back to a previous version. And by default, this will give you an error that says, oh, are you sure you want to do this? Because there's like no way back, right? Why are you trying to remove everything? Maybe there's a valid use case to remove it, but we'll give you a warning and says, please use a value less than 168 hours, which is 7 days. But you can override. So you can say, you can essentially set the check that's doing this check to false. Say, oh, don't check for me. I'm sure I know what I'm doing, and I'm going to remove everything. And this essentially, this line adds a command to the transaction log that says that somebody did a vacuum. So let's run this now. And now it'll work, but it won't do anything. Why is it not doing anything? Because we did it as a dry run. A dry run is what you should do to verify what are all the Parquet files that you're actually getting rid of, right? So it's going to give you a list of all the Parquet files that the vacuum will get rid of, but this is your way to check it. So you look at it and say, oh, I am getting rid of all these Parquet files. If you wanted to do like a programmatic check, you would open your latest JSON file from the transaction log. You would ensure that none of the files in that JSON log are part of this list, right? So you have a list. in your latest transaction, you have a list of files that are getting removed, and these should be mutually exclusive because that way, that's just a way of checking. But that's essentially what we do as well, but it's your way of checking. So now we're going to do this and get rid of all of those files. And if you do that, you'll just get a command back saying that, oh, I did everything. And this is sort of the location that you should go check, essentially. So let's wait for it to run. So you see, there was a small message that said computing snapshot for version 11 and says, okay, this is the path of the table, right? So it's not really telling me anything much apart from the fact that it succeeded. But if you go query that location, right? So you get this path and then you go query that path. You'll see it has just one Parquet file. Why? This was the Parquet file that was written as part of version 8, and then we deleted in version 9, and then we restored 10 to 8, and then we have 11 now. But it's all that one file, that final file that is required to query the table, right? Now, if I go back and do version 0, select star from table version 0, it is not going to work because I deleted those files, right? Now, in this case, you'll see it coming back. That's because this is cached. But if you restart this cluster, it's going to go away. Essentially, this data doesn't exist on file storage anymore because obviously the Parquet file that I could read to get it back is gone, right? So yeah, that was the sort of the first notebook. And at the end, please run this cleanup script so it can just clean up your environment. Hopefully that was sort of a useful exercise. Again, that was just to give you a flavor of all the possible operations, right? So you got an overview of optimize, you got an overview of vacuum, z-order, restore, right? So all of those interesting, useful operations that you could not do without Delta, right? You would not be able to do most of those things with plain Parquet. If everybody's following along, we did 3.2, and we're now going to jump to 3.4, which is set up Delta tables. And we'll just go to that notebook. And again, just run your classroom setup script, which is on command 4. And I'll just walk you through how you create tables. There's a few different ways in which you can create tables, right? So if you're familiar with SQL, you've probably heard this statement called CTAS, which is create table as select, right? Which is you have some data somewhere, and I want to create a table based on that data that's somewhere. This could be another table, but this could also be pointing to a location in object storage. You can, we'll talk about how you can add sort of useful metadata fields to tables. We'll talk a little bit about generated columns, which is a really cool feature that Delta added. And we'll talk a little bit about quality enforcement, but we'll leave the quality enforcement part to Delta Live Tables because it does it in a much more sort of, well, there's more controls that you can enforce on DLT. But we'll talk about it in this case as well, right? So here's the simplest way in which you can create a table. If you have a Parquet file sitting somewhere, a Parquet table sitting somewhere on cloud storage, you can just say, create or replace table sales as select star from Parquet. That's it. And now you've created a Delta table, which is a sales table, which was sourced from the Parquet files that were sitting here. Now, obviously, this is a small table, so it doesn't take long to run, but you'll see that it got all the data types and even there was an array, a complex data type, everything, because Parquet is a self-describing format, right? It enforces a standard, it enforces a schema on the files itself. So you are able to enforce that same thing on the Delta. Like we can read that schema and build the table for you. Again, this is a managed table and it's in provider's Delta because when we say create table, by default, it's Delta on Databricks today. Okay, now what can you not do? You cannot support a manual schema. So if I wanted to tweak the schema somehow and say, no, I don't want an int, I want a string or whatever, you can't do that because the CTAS statements cannot support that, right? There's another way you can do it. But for create table as statements, it's useful for these well-defined schemas such as Parquet and other structures like maybe ORC and stuff that come with the metadata with it, right? Okay. Why is it a problem for non-describing formats? Because as this example will show you, if I do the same thing, reading a CSV file, I will end up with something like this, with everything stuffed into one column, and there being like no idea like what was the column separator, how do I split this row, like no idea. So that's why it doesn't work for CSV, right? But for Parquet and other formats that support well-defined schemas, it will work that way. Okay, so how do you do for CSV? Well, there are many ways to do this for CSV. One of the easiest ways to do it is defining a temporary view like this with the columns that you want, any data types that you want. And now you're saying using CSV, right? Now notice you haven't written anything out. So I want to read this view as a CSV, not as delta, because I just want to bring this CSV. I want to give the CSV some structure. So I'm still using CSV. And now you can give your options. Say, oh, it exists here. It has a header and the delimiter is 5, which we noticed from here, right? So we know the header is here and there's a delimiter. So now if you give that, you create this view, and then you create the table as a select from the view. So the view is essentially just a temporary placeholder for that logic to read the CSV file, and then you create the table. Now again, you ended up with a sales delta table, which is a delta formatted table, and you read it from CSV, but you got the structure, right? And yeah, so you got the structure from there. Okay. Now, what we have seen a lot of organizations do is create tables that, but try to do a cleanup at the same time, which means today, historically, maybe I had 100 columns in a table, but I realized that 20 of these are never used. They have no value. They're null all the time. So when I create a new table, why do I need to bring along these 20 columns, right? Or maybe it's for another use case where I'm creating a table with just a subset of the columns for some other specific consumer to read from, and I don't want to give them the whole table. So in that case, you can do just a select from your whatever table that you have, but you don't need to read all of the columns. You just create a new column, new table with just a subset of the columns that you want, right? So this is another way in which you can create sort of targeted tables for specific personas, right? You could also do this as a view, but then for the view, you still have to read the entire table, but with the table, you're rewriting just what you need. So you can sort of manage it and separately, govern it separately, which is a good thing to have, which is what it's saying here, right? So we can do the same thing with a view, which is on command 14. You get the exact same results, but in this case, we actually created a table. And in this case, we just create a view directly based on that, but it's the exact same thing. So if you just want to create a view, you can, but you could also create a table for the use cases that require. One really cool feature that Databricks has added is this concept of generated columns. So a lot of customers wanted to add columns to tables that could add additional information to that table as it's being created without having to write ETL for it. So what you do is you add that logic, this logic on a new column, but you put it in the actual create table state. So you say, okay, create or replace table purchase dates, and you say it is generated as another column that was part of the input data set, right? You can add a comment to it. Let's see what happens when you do this. So my table actually has an ID, a transaction timestamp, and a price, and then this date is a generated column. So we are going to try to insert, actually this is purchase dates, and we're going to merge into purchase dates some data from the purchases table that we created earlier. And let's see what happens, right? So this merge should work fine, but let's query the table. So now you see I have ID, transaction timestamp, and price, but I also have the date. And how was the date generated? The date was generated automatically by this syntax here, right? So you define that logic in your create table statement and just let Databricks generate it for you. Every time a transaction comes in, it's going to essentially call that function and generate a column for you. And you could have any number of columns. Maybe you have a case statement with some logic. You can do all of that stuff in the create table syntax itself. Let's try to break it. Now, let's say I was trying to insert this row into that table directly. I get a check constraint. Because each generated column essentially in the back end is generating a check constraint on that column. And it says, well, if I were to take 202618 and plug it into this function and divide it by 1 to the power of 6 zeros, then I don't end up with an actual date. I end up with something like this, which is, it's not correct, right? So, I mean, sorry, I end up with 18431, which is not a date. So if you have a generated column, you cannot insert a row into it that violates that constraint because essentially it's a table constraint. You can insert manually all day long as you follow the rules for this. So it should be something like this, which is a Unix timestamp, because that's what we are expecting over here. We are expecting a Unix timestamp that we're going to divide by 1 followed by 6 zeros to get a timestamp and then convert that to a date. So which you cannot do with this, right? Which is why the insert failed. Now, the check constraint was automatically generated because you created a generated column. But can you create a check constraint without a generated column? Well, sure. You can add what is called a table constraint. And what you'll do is you'll alter the table and we'll add a constraint and say, okay, the valid date has to be greater than 2020-0101, right? So if anybody gives me a date that is they're trying to insert into this table that is of a lesser value, it should fail. And you can inspect this in your table properties by doing the describe extended. And if you scroll down, it'll say, oh, there is a constraint. It says valid date should be greater than 2020-0101. So this is great, right? You can inspect this. Okay, so let's talk about one more thing. There are few other interesting things that inbuilt functions that you can use to enrich your existing tables. And this really helps when you think about the fact that you want to populate, let's say, your bronze or your raw table from the source, but you want to add a few fields to it because you don't want to modify anything from the source. You want to add a few enriching fields that give you some additional information, right? And so we'll show that in this example on command 28, which is going to create a table called users PII, and it is partitioned by first touch date. And we'll talk about partitions in a little bit, but it's doing a select star from a bunch of Parquet files. But it's not just doing a select star, it's adding 3 new columns, right? It's saying, okay, I want to cast that first touch timestamp as a first touch date. I want to use current timestamp and put it in a new column called updated. And I want to use the input file name as a source file. So now you have 3 additional sort of metadata columns that you're populating when you create the table directly from your Parquet files, right? So your Parquet files didn't have this, but you could think of this logic as something that you could put in your ingestion pipeline. So you populate these fields each time a file comes in. And if you scroll to the right, it's going to tell you first touch date, right? Because it converted this to first touch date. It's telling you the current timestamp of when this row was actually updated. And it's telling you the file it came from. So now if you get like a bad file or like somebody restates the file or something, you can actually go back and audit and check, oh, this file was the cause of the problem, right? Again, you can run this describe extended. And let me see. Oh, one thing I want to show you, we had been so far looking at managed tables. This is an external table. And the reason it's an external table is because we provided a location. So this is the only way in which you can create an external table on Databricks. And this is true of today's world where you are on the Hive Meta store, tomorrow, if you adopt Unity Catalog, Unity Catalog supports locations for meta stores, catalogs, schemas, and things of that nature. But a table is always external only if you specify a location. So anytime you don't specify a location keyword when you create a table, is going to be a managed table. So just remember that. If you want an external table, always specify the location when you create it. Let's look at this. Yeah. So this exercise is just trying to show you how Parquet is laid out on cloud storage. You're probably familiar with this, but when you partition a table by a column or a set of columns, essentially you lay out directories, subfolders on cloud storage, right? So in this case, first touch date was a partition column we mentioned here, partition by first touch date. So that's how the data is laid out. Now, note this comment here that says you should default to non-partition tables. So what we say at Databricks today is if your table is, give or take 1 terabyte or lower, don't bother with partitioning, right? There is some value in partitioning when your table sizes get bigger and bigger, and there may be valid use cases where you do need to partition by date or anything like that, like we did here. But it has very sort of diminishing returns for smaller tables. So instead of partitioning, just don't partition and then use Z order by the columns that you want, like your most commonly used predicates. How are your users querying this table? Is it by ID, by date, by something else? Use those columns in Z order so that essentially we can get to the data faster and the files don't have to be separated across cloud storage, right? Because imagine a customer ID 1 is there in date in each of these, right? So imagine there's a customer ID 1 in this date, this date, this date. If I do a query that says select star from table where customer ID equals 1, we have to physically open each of these subdirectories and each of the files, Parquet files in these subdirectories to get to customer ID 1. So it has like not a lot of value in smaller tables. When it comes to bigger tables, it does have some value, but just talk to your sort of Databricks solutions architect to understand when you should do that. Okay, let's wrap up this notebook. There's like a couple of things. So one is this concept of clone. So I mentioned right at the beginning that when you think about time travel of a table, don't think of that as a way for you to sort of, plan for disaster recovery or anything like that, right? Time travel is a very is a way for you to go back to a list of transactions for a limited period of time, not to the end of time, right? So if I want to see a version of a table in that was 2 years ago, it doesn't make sense to time travel back on the main table. Instead, what you should do is you should do a deep clone, which actually copies that data over to another table. And you can run this to say clone as of version, a date, or as of version or a specific version. And then you can do that as snapshots. So for example, think about it. You say deep clone purchases as of date January 1. And then you do deep clone purchases as of date February 1. So you're taking monthly snapshots of the data. And that is a way more efficient way in which you can maintain a history of a table, because it's unlikely you will need each of those tiny transactions that go, thousands of transactions that happen in a table every day. That's good for a limited period of time, not for long periods of time. So deep clone is your better way to do that. And you'll see that 4 files were actually copied, right? So the source table was this, and it actually copied into a different directory and created a new table for us. And you can look at the describe history for this to see what it did, right? And it'll tell you that this is version 0 because it's the first time I did it. And it copied it from this table here. And it was using this notebook, this cluster, and it's going to give you a bunch of operation metrics, like how many files did it remove and things of that nature. Right? And deep clone is incremental. So if I run this again and again and again, it's only going to copy over the files that you committed since the last commit. So it's not going to copy over everything else. So deep clone is an incremental way for you to keep snapshots of your data for historical reasons. There's another clone, which is shallow clone. Shallow clone actually does not copy over the data at all. So you'll see copied file size is 0. So it didn't copy over any data. What it did is it created another table, but pointing to the same transaction log as the previous table. And this is good for, like, you want to share a copy of the table for some quick experimentation for your ML team or for another team, but you don't want to share the main table. You create a shallow clone for that, right? But again, it's not meant to be for any historical retention purposes. For that, you should use the deep clone. And if you do a describe history here, we will see that it did not copy over any files, right? So nothing was copied over. It's just, it knows that there were 4 files in the source, and it can point to those 4 files when you try to read from it. So yeah, so that's brings us to the end of this notebook. And I was hoping to finish one more notebook by this time. So let's see how big this one is. If it's not, we'll skip to, actually, let's do this. It's kind of useful exercise. We'll do this, and then we'll take a 5-minute break. So if you finished 3.4, please jump to 3.5, which is how to load data into a Delta Lake and run your setup script. And there are a couple of things that we discussed already. We already did create or replace table in the previous one. We called it CTAS, but if you notice the syntax, we actually did create or replace. CTAS is just create table as, because we didn't want to run into the issue of a table already existing for demo purposes. So create or replace table events is, it fully replaces the contents of the table, as it says here, each time you execute, right? So you're cleaning out your table each time. You don't care about what the previous version was like. You're just reading the latest content of wherever your data is in, and you're replacing the entire table. And if you look at this history of this table, you'll notice that there was a version 0, which was actually a clone, which was done programmatically. And then this is the statement that we run and create our table. So this clone was actually set up for us as part of the whole setup experience. There is another way in which you can completely rewrite the table, contents of your table, and that is insert override. So what is the difference? The difference is that insert override can only override an existing table. So if you do create or replace table, if the table doesn't exist, that's fine. It's just going to create it, right? But insert override, you can only do with an existing table. Insert override has a limitation, or I would say a feature, that allows you to prevent the insertion of bad data into your table, because you have defined a schema for that table. You want to override data into that table, but you want to ensure that the schema is not messed up. So that's when you use insert override, right? So that's why it says it's a safer technique. And you can also override individual partitions. You don't have to override the whole table, which is not shown in this exercise, but you can. Whereas with the create or replace table, the entire table is overridden each time, right? So we're doing insert override sales, and it works fine. And if you look at the history of this, you'll see it's slightly different. It says it was a write operation. If you go up here to the previous one, it was the create or replace table as select, right? And if you come down here, it's a write. So it's a slightly different operation, and they have slightly different heuristics they follow in turn. So like I mentioned, a CRAS will allow us to completely redefine the contents of the table. A completely new schema doesn't really matter. But insert override will fail if you try to do something else. And we'll demonstrate this by writing this insert override, but we're adding a new column on the fly, and it will fail because it's saying, oh, you can't. A schema mismatch was discovered, right? So yeah, we can't insert override and make schema changes at the same time. So just keep that in mind. Awesome. You can do it with replace where, which a lot of customers do, but by default, you can't. So you have to add these options in order to override those options. Cool. Now insert into is another way in which you basically do appends, right? Insert override means you're rewriting the entire table. But insert into is you're just doing a pass. I have 30 rows. I want to put it in, do an insert into. You can also do, note this thing, insert into does not have any built-in guarantees for preventing inserting. So if I write this, if I run this query like 10 times, essentially I'm putting 29 records in 10 times. There's nothing preventing this record from going in, right? Okay, so let's do a merge. Because we want to actually bring that current timestamp in, but we can't do it with a typical insert override. So what we're going to do is we're going to merge into that table by using a temp view and merge into our target table users using a join key and give conditions. So when matched, do something, update this, update, right? And when not matched, insert. So this is a traditional sort of what you would think as upsert operation, which is just an update and insert. And we're not doing any deletes, right? We're just doing only updates and deletes. So it's what you would traditionally call an upsert operation. And so many rows were affected, 72 rows were updated, right? So 911 inserts, and great. The really cool thing here is you can actually do an insert only merge, right? So imagine your source system has a lot of duplicate records that for some reason they sent you the user ID and the event timestamp like twice. You don't even have to like detect the fact that there were duplicates, because when you do the merge, it is not going to allow the duplicates to be inserted, right? Which is a really cool way in which you can do a merge. So you can do an insert only merge. You can do a traditional upsert merge. And like we saw in the previous notebook, you can do an update, an insert, and a delete all in a merge. So the options are sort of, all there. It's really what you want to do to satisfy each of your use cases. There's another way in which you can insert data into a table, and that's called the copy into. So copy into is basically an idempotent operation. What does idempotent mean? Idempotent means it doesn't matter if I run this command 1 time or 100 times. I will not copy the same file into the table 100 times. I will only copy it once. So this is actually a way in which a lot of our partners bring data into Databricks, right? If you've heard of partners such as like Fivetran or other ingestion partners who actually, take data from some cloud staging location and put it into Databricks, either through our partner connect or their own jobs, what they are utilizing under the hood is copy into, because copy into guarantees that the same file will not be picked up and written into the same table twice. But if there are duplicates in that one file, we cannot do anything about it, right? That's why it says duplicate records should try to be excluded or handled downstream. So if you know you have duplicates, you have to build some logic to remove the duplicates and then do the copy. Or do it downstream after the. Awesome. So I'm going to stop here and see if there is any other questions that we can take at this point. But we will take a 5-minute break and we will jump into Delta Live tables. I'm going to add a timer here. So just so everybody can get a breather. Okay, so we have 5 minutes. Use the bathroom, have a coffee, whatever, or just catch up with the exercises, and we'll start back again in 5 minutes. So it's 12:24 Eastern for me. So like 5 minutes to 12:29 we'll start, and then we'll have like an hour to go for the DLT session. But yeah, if there is anything else, let me actually see if there's any questions. There was a question about how to download this. So there's a couple of ways to do it. So there is a GitHub link that you can just Google. It's a public GitHub link. So if you Google Databricks Academy Data Engineer Learning Path, you will end up at this page, and then just go to the releases page. And this version V102 is what we are following today. Obviously, we are just doing the modules 3 and 4, but all of these other modules are there. And you can download it from here. You can even clone this to your to the repos in Databricks, if you're familiar with that. The other way is if you are in the workspace, you can just come back to your workspace and go here, right at the top level, and say export. And say export as a DBC file or even a source file. And what this will give you is this will give you the entire content as a zip. And then you go to your workspace and go to any folder that you want to bring it in as. So for example, I would go here to like my home folder, and I might create a new folder here. It says like this and say for import, right? And you can import it here, right? So let me actually demonstrate it. So I could export this as a DBC, and it should get downloaded. And then once it's downloaded, I would go to the import. There you go. And I would say import, and I could browse to my home. Came here and say open, and it will bring it in here. And I could say import. And this can be done for various formats, right? It's not just DBC, but in this case, we are doing an import of a DBC. So we're doing a DBC. But it'll import that whole thing. So either you can import yourself, or you can just go to the GitHub link, just search for Databricks Academy Data Engineer Learning Path, and you'll be able to clone that repo to your Databricks workspace. Also, there was a question about the Databricks Professional Data Engineer certification. That course is actually going through some changes. So you can still take it at the Academy, but we're not doing a public sort of training of that at this point. It'll probably be in the new year. So our quarter starts in February. So it'll probably be at that point when we think about it. Yeah, nothing for that yet. Nothing like that for this kind of session yet. But the content is available in the Academy. Like I've been following it myself. Awesome. So I'm back. Our timer is down to 0 seconds. So Google was letting me know the timer has run out. We'll get started since we only have less than an hour. Hopefully some of you saw me exporting and importing the notebooks if you want access to it. But like I said, it's also available in our public GitHub. So just go to Databricks Academy. You can just Google for it. Just Google Databricks Academy and Data Engineer Learning Path and you'll find it. Awesome. So let's keep going. we are going to go to section 4, which is delta life tables. And before that, let me just quickly show you or tell you what delta life tables sort of tries to solve for. You may have heard of us talk about this multi-hop architecture. Either, I may have mentioned it, others, you may have seen it in our literature or in other decks and demos that we've done. In a very simplistic fashion, what it really means is, how does data get from point A to point B, which is your source and your destination, your target, right? And in this case, when we say point B, we are talking about the final cleansed aggregated data that your consumers use, maybe for BI reporting. What is the actual curated data that everybody can trust? And how does data get from point A, which is raw, messy data, to point B? And we call that the multi-hop architecture. So this is a very simplistic diagram again, and it doesn't have to be bronze, silver, gold. It could be raw, bronze, silver, silver 1, silver 2, gold, platinum. It's really up to whatever works for your organization. But at some point, you have a clean data set that people can consume, right? That's not to say that you can't do machine learning or data science on any of the other data sets, because it's really important to have the full data available in these layers to enable those use cases. And again, one of the advantages of the lakehouse architecture is that all of this data is now sitting in your lake. So if you willy-nilly wanted to join bronze to gold, you can, as long as you have access, right? So you're enabling some use cases that may not otherwise be easily possible if your data is siloed in different systems. So what is bronze? It's typically a raw copy. We recommend that you do no changes to it. Think of it as your source system that sent you this that file is no longer there. It disappears tomorrow. The company went out of business, whatever. The source file doesn't come anymore. How will you go back to that source file? You can't. So when you bring it in, keep it as close to the source as possible. Don't make any modifications that you'll regret, right? Because you may add some business logic in there, says, oh, if it's code equals 1, then 100 or something like that. And then when you have to reformat that, when the rules change, you're stuck. So don't do that at the top. Do that in Silver, right? This is where you will traditionally keep all of your data. So, cost considerations aside, cloud storage is still the cheapest part of the cloud. If you have petabytes of data, where should they exist? They should be in bronze. And then the amount of data that you move to silver and gold, you sort of think about for each use case. So silver reduces the data storage complexity, because at this point, you will start whittling down from bronze to silver. Either you're adding, removing, getting rid of bad data, whittling down with filters, enriching it with some other fields, converting timestamps to dates, whatever, right? All of this stuff happens in silver. And if you're using Databricks, obviously, you will be able to take advantage of the fact that you can read read at a high performance from Delta, but also write at terrific throughput, right? We can write I don't know, lots of thousands of rows per second. We have customers who want to write, gigabytes and terabytes per second, not in a table, but in general throughput, right? So that's where Delta really shines with helping you write that data out as fast as you can. Obviously, Delta doesn't work in a silo, it works with Spark. And because we sort of originated both, we can make them work as best as they can compared to anybody else. Again, don't do any aggregations here. Try to keep it at the same grain. Get rid of all your dupes, data cleansing, all of that. This is where you should start enforcing schema. So in the first step in bronze, just bring it in as it is. Even if the vendor is sending you some data type that doesn't make sense to you, don't modify it there, because you want it to be as close to the source as possible. And then you start building your data quality checks and your schema enforcement and everything starting with silver. And then you work your way through. Maybe you have one silver table, maybe you have different layers. That's totally fine. It's up to you. And then you go to the gold layer, where you give your curated, aggregated, cleansed data set for the consumers that actually want to use that data to power, either BI or ML applications. At this point, you can start eliminating columns in terms of what you want to display, right? Silver may have a lot of columns. You don't want gold to have all of those columns. And you can optimize your query performance, like I said before, like because Databricks is invested like tons in trying to optimize making your queries on the lake as fast as they can be on a warehouse to the extent possible, right? Obviously, we're continuously trying to improve that. And why does Delta Live Tables help with all this, right? So Delta Live Tables helps because even though we saw a nice green, clean picture of bronze, silver, and gold, that's not the reality. The reality is more like this, where you have, n number of sources, X number of silver tables, and then Y number of gold tables, and it goes, crisscross. Nobody is sure which pipeline owns what. There are hundreds of jobs writing to one table, etc. So you want to avoid all of that. We want to give you a very clean and easily manageable way of managing these tables. So it's very difficult to maintain table dependencies, right? So if I give you just a random table in the silver layer and ask you, oh, what are all the tables that feed this table? You would not have an easy way to answer that without you going and writing some code and trying to figure out which jobs are writing, and it's quite painful. Traditionally, you would write batch processing, right? Even if you're doing Spark, you would be Spark read and read stream and write stream, or not, just read and write. And you would have to make a choice as to when do I switch to streaming and when do I not, right? Now, our opinion is generally that you should always adopt a streaming architecture, because all we are really arguing about at this point is the latency of the stream, right? A stream doesn't always mean just flowing through 24/7 as just a mind shift change that we need to do. But we can unify this even easier with DLT. We're going to give you DLT, data quality and governance right out of this, right? You build your constraints, just like how we showed in that constraint example, but now DLT is going to be able to report on it. And it's going to give you options. It's going to say, do you want to drop this row, or do you want to keep it, or you want to report on it, or you want to fail the table? All of these options are DLT is going to give you. And it's going to give you a lineage of all the tables that are in a pipeline. And obviously great observability, because you can monitor your pipeline very easily, like which table failed, what happened, all of the metrics are exposed easily. And recovery is great because you can recover a DLT pipeline from the point of failure, like you can rerun the entire tag, or you can refresh just a table in the pipeline. So, which is a very cool feature, and I'll show you. Okay, so what do we want to do with DLT? We want to make developers, data engineering teams really agile. A lot of data engineering teams spend hundreds and thousands of hours trying to orchestrate and manage the code they wrote. And we are saying, you just worry about the code you write. Forget the orchestration and the managing. We'll do that for you. That's essentially DLT's sort of selling point, is that you focus on writing the code. That's what you're really good at. Write the best code that you can, and then be done with it. Create it as a pipeline, and let us do the hard work of managing it and guaranteeing you that this pipeline is going to run and all that. And so if something goes wrong with it, you can point the finger at us rather than you point the finger at yourself, right? So think about it. It's sort of a shared responsibility model where you write the code, but we'll manage the pipeline. And you can trust your data because we're going to give you all of this data governance built in. And you can scale because DLT has a much improved, enhanced auto-scaling algorithm that works for both batch and streaming use cases. And DLT is primarily sort of a streaming first mindset. Batch just happens to be something you can do as well. How do you do it? All right, super simple. It's very declarative. You can do this in SQL or Python. You say create streaming live view or create streaming live table. And then you'd say, this is your raw table. It's reading from cloud files. Cloud files is how we refer to autoloader. Autoloader is basically a way in which you ingest data directly from cloud files, from cloud storage, whether it be S3, ADLS and all that. And then you define your tables on top, right? So imagine you're sitting down and writing this code. You are writing this code. You know you have to source the data. You know you have to create a bronze table on top of it with some logic. You know you have to do some silver table based on some specifications somebody gave you, right? You're doing all of this. The closest thing that I can think of is back when I was an ETL developer, somebody would give me a source to target mapping document and say, here's the source to target mapping document. It goes from here to here to here to here. And I would have to sit and write it. Well, when I'm writing that code, what DLT is asking you to do is just sit down and write that code. You know the transformations, you know the logic expected, you know what you're supposed to do, just sit and write it. And once you write it, let the pipeline do all the work, right? Don't worry about chaining together tables, we'll do that for you. Don't worry about retrying your pipelines, we'll do that for you. That's essentially the selling point, right? And plus you'll see all this leniency, like we talked about earlier. It was very difficult to figure out which source fed into which table in the past. And we'll give you data quality, right? So you can define a constraint just like we did on the normal Delta tables. But on the normal Delta tables, if a constraint is violated, you'll see an error. Like when we try to insert that row that violated that timestamp constraint, we saw an error. But in DLT, you have a control now to say, it's fine, I don't want to error the pipeline, just report it in the logs, right? Or just drop the row, depending on your choice. So you can either drop, or you can let it pass through and report on it, or you can fail the pipeline. Fail the pipeline would be sort of the last resort. Okay, that's that was all with the decks. Switch back to the notebook, and we will go to DLT 4.1. You probably are already connected to a cluster that you have. So the first thing to do is run the classroom setup notebook. And this is going to be a slightly different exercise than we've done for the other ones, because it requires you to move over to the workflows tab and do some activities there. But I'll walk you through it. So far, we've been in the workspace and we've been doing all this. To run a pipeline, you will have to navigate to the workflows tab. So if you go click on workflows here, I prefer to right click and open link a new tab so I can sort of see it side by side. So here's my new tab. I'm going to the workflows section here. And if you go to the workflows section, you'll see a job run, and a delta live tables. And we're going to start with the delta live tables, right? So let's flip back to our notebook. So just remember, it's easier to work if you have two tabs open or two windows open, whatever works for you. I'm going to switch back and forth between these two tabs. So again, it's using a bunch of pre-populated data sets and paths for us, unique to you again, so that you don't collide with anybody else. Now you have an option. In command 6, you can either choose to work in SQL or work in Python, and you don't have to write any code or anything. So it's just both will give you the same experience. And for your reference, you can see the code here. 4.1a is the SQL pipelines code, which has 3 notebooks: orders, customers, and status. And 4.1b is the Python pipelines code, which also has the same. So it's the exact same code. Everything is the same. We'll look at the code a little bit later. But what we're going to do is create a pipeline using this code. But how we're going to do it is by using the help of this walkthrough notebook. So what you have to do is, I'm choosing to use SQL. You can choose to use Python. You can just do control / to comment it, or just do hash and just run this. And then if you run this cell, you will get a bunch of information that you're going to use now to create a workflow. So let's look at it. So the first thing is a pipeline name. So what I'm going to do is I'm just going to copy this pipeline name, right? Before that, let's scroll down a little bit and see how to create and configure it. So what we're going to do now is essentially flip to the workflows tab and do all of these steps. So you're going to click workflows, you're going to click delta live tables, you're going to click create the pipeline, and product edition we'll choose advanced. DLT has 3 levels of data quality stats and features that for our exercise we'll choose advanced. And then we are going to add all of these details, right? It looks complex, but it's not that complex. And just for note, we don't need to add notebooks 2 and 3. We will just add notebook 1. Okay, we'll add 2 and 3 later. That's to show you how, when you develop a pipeline, you don't have to have your entire pipeline built out. You can go in stages, right? So awesome. So let's copy this and let's flip over to our pipeline delta live tables tab in workflows. and say create a pipeline. Now this will give you this UI with a bunch of options, and I'm going to paste the pipeline name here, which is sort of unique to me because it's my instructor name. And you can see that the product edition here is by default advanced. And if you want to read about this, you can just click the help me choose. And you can see that basically there's a few features in the advanced, like more data quality expectation rules. If you are interested in change data capture or slowly changing dimensions, those are in the advanced. But you get all of the normal advantages of DLT just with the core edition as well. So anyway, we'll choose advanced. We're going to choose triggered. If you choose continuous, it means you say running this pipeline 24/7 all day long, every day, which is a valid use case, but we don't need to do that for this. You don't have to choose anything for cluster policy, but just a note, you don't have to have cluster create privileges to create a pipeline. What your administrator should do is create a cluster policy specific to DLT and give you access to that cluster policy. And then what you would do is essentially you will come here and choose that cluster policy. Okay, flipping back, what we need is the notebook path. Yeah. So the notebook one path, you're going to copy the notebook one path and come back here and just paste that here. You could also navigate to it from here if you know the path, but the nice thing is you can just paste it as well and it will detect that, oh, that's where I wanted to go. And we're only adding this 411 orders pipeline. We're not adding the other two yet. Storage location. So storage location is what is the cloud storage location on which you want to store your data. Meaning when this table is written out, obviously the metadata, like we'll have a pointer in the Hive meta store, and that's what we define here by target schema. But where do you want the actual data, like the terabytes of data to be stored, right? That's your storage location. Okay. So we'll give that this target is the schema. So just copy that, put it in target. So this is going to be your database name. So this is a new database that we're creating to populate these tables. You don't need this policy. I don't think this policy exists in our workspaces. So that's it. So now you can do these other things. You can say add configuration, key Spark master, but you don't really have to do it. If you want, you can, but you can choose to skip it. What you have to do is come here and do add configuration and say spark.master and put this value. Again, this should work even without this. This is us just trying to stick to one, basically running in like Spark local execution mode on a one node machine, right? This is important. The source is important because that's where our data is from. So we're going to add source. We're going to navigate back here, and if you scroll up, you'll see a source. So we need to copy the source, and we're going to put that here. Okay, and channel is essentially instead of Databricks runtime versions, which you may be used to in the data engineering side, DLT is a managed runtime. So you just get to pick current channel or preview channel. Preview has like more features or the later features that will eventually come to current. For now, we'll choose current. It also tells us, I think, to not use enable auto scaling. So num workers to 0. Disable auto scaling. Okay, we can do that. This is an older instruction, so I wouldn't really worry about this. I'm going to leave this at one to two workers and just run it for now. And I'm actually going to get rid of this as well. Okay, so again, you have some flexibility there. The most important thing to remember here is you can add as many notebooks as you want. So later on, we'll add notebook 2, notebook 3, everything, right? You can add as many notebooks as you want. And that notebook could have code in any order that you've written. It doesn't really matter because what DLT is going to do is read all of those notebooks at the same time. And it's going to create a DAG of all of the objects in those notebooks, all of the tables in those notebooks by itself. So you don't have to create the DAG, which is the really cool thing about it. And you can even have commands written in weird order in the pipeline in the notebook, and it'll still work. So let's create this. what happens. Okay, so this, I already had a pipeline by that name, so I'm just going to do example pipeline 2. Okay, so now you note that nothing exists. It just says a graph will be generated here once a pipeline update is started, right? And if you are following along, you can actually run this validate pipeline. I will get an error here because I changed the pipeline name. Oh, it saw my old pipeline, but it's saying I am expecting to see 3 notebooks, but I only saw 1. But that's fine because we're doing it in steps. You don't have to do anything else. So you can go back here, and now what do? You do start. There's another option, say full refresh all. Now, because this is the first time we're running it, it doesn't matter. But if you had run this pipeline, for weeks and months, and then you wanted to full refresh all the tables again, you have this option. Otherwise, it's always going to be incremental. By incremental, I mean incremental data flowing through to your entire data set, meaning like your tables could be complete, but your data is always incremental, right? So again, let's just do start. So what's going to happen here is it's going to take a few minutes for the resources to be spun up. And that resources being spun up is essentially a cluster that is going to be spun up. And we can see that by going to the compute tab. So just hover over the compute tab, do a right click and open a link in new tab. And if you go to the compute tab and click on jobs compute, you will see a DLT cluster being spun up, right? So DLT spun this cluster up for you. You didn't have to specify anything in it. And if you click it, it'll give you this sort of custom Databricks runtime, right? Which you didn't decide, right? You only picked channel, and DLT is picking that runtime for you. It picked some default instances, but all of this you can control through the cluster policy. If you wanted to use different types of instances, you can do it in the cluster policy. It will also add a whole bunch of Spark tags here. Actually, it's easier to see it in the JSON. You'll see that DLT had added a lot of sort of pipelines, Spark configs, right? This is why it's a managed system. We don't expect users to be able to remember which configs to use for what purpose. Forget about it. Just let us do the work, right? That's DLT's value proposition. Forget about all of this stuff. We'll do it all the work for you. So it's going to do all that. All of this stuff like AWS attributes, if you want to use on-demand Spot, all that you can control through the cluster policy as well. And that's all. Now you just wait for sort of the instance to come up. It may take a few minutes. And once it's up, what will happen is this DAG will get populated. So DLT has like a few pre-steps it needs to do, right? One is it obviously needs to create a cluster because it's creating a custom runtime image. And there are 2 modes, development and production. Development means once we spin up the cluster, we're going to keep the cluster up for 2 hours, right? And again, there's a config that you can use to shut the cluster down in right after the job is done. But it's useful because think of what we're trying to do now here. It's a development mode cluster. It's going to take like 5 minutes for this cluster to come up. I'm going to come back in here and I want to add, notebook path 2 and notebook path 3 to that pipeline after I'm done with it. But I don't want to wait 5 minutes, again, another 5 minutes for the cluster to come back up. So the development mode is meant for you to keep the cluster up for a longer period of time as you develop. So, you add some code, you come here, click start, change some code, come here, click start. And during all this back and forth, you don't want the cluster to go down. And that's what the development mode is for. The production mode is for when you want the cluster to actually be shut down right away. So you want, in production, you want the job to run and turn off the cluster. But in development mode, you want to keep iterating through, which is why we have these 2 modes, right? So once this cluster is up, I'll show you what happens. But before that, I'll switch to the other pipeline that I ran, which is the exact same thing. And this includes all of the 3 notebooks that we had, right? I'm just showing you what it looked like at the end. But notice I didn't create this DAG. I didn't create these dependencies. I didn't drag and drop anything. I just wrote code. I wrote code that said orders by date has to read from orders silver, for example, and DLT created this this DAG for me, which is a really cool feature when you think about it, because it takes the headache out of orchestration, right, out of your hands, and you don't have to worry about it. Let's see if our pipeline is up. It's still initializing. So let's go back again. I'll walk you through the UI. So like I mentioned, there's development and production. But for each table here, it will also tell you the paths of the notebooks that you used for that pipeline. It's going to give you some update details, like how long did it take, what was the last time it ran, what was the runtime, things of that nature. It's also going to give you how many DBUs you used for that specific run, what was the cloud you ran it on, what was the product edition which was advanced, and the DBR version, right? And as anyways, you can click the Spark UI logs metrics to get to all the familiar things that you're used to on Databricks. All of that is not taken away from you, right? We just want to take away the headache. We want to give you all of the other good stuff. Let's see if this is back up. Okay, so now you see it as progressed past waiting for resources. It's doing initialization. It's doing setting up tables, and after that it'll render the graph. So what it is doing is actually trying to read through your code to figure out. And okay, so we had only one notebook, and that was the orders notebook, and it had bronze, silver, and this orders by date. So now it's running, and you will see this flow sort of refreshing on the fly as it's running. And when it's done, it'll stop. You say this is queued because this was running, and now it's running, and you can show all of these things as events here, right? And if you have warnings and infos, you can errors, you can still see it. Okay, so now this pipeline is done, right? This pipeline ran. It took like, I don't know, less than a minute. It took way longer to actually set up the resources. If you go back to our compute page, here, this DLT cluster that was spun up is still active. It has not been shut down. So our pipeline finished, but the DLT cluster is active. That's because we are in development. So now what we're going to do is take the second notebook and go back to our same pipeline, and I'm going to edit it by clicking on settings and saying add notebook library. I'll add the second one, which is customers. And now we'll add the third one as well, just so we have a full picture. Okay, so note how that worked, right? Because I have not yet written the code for customers and status, right? That's a scenario. I only wrote for orders. And then I created the pipeline, I ran it, I verified everything's working. At the same time, I'm starting to write code for customers. I could be writing code for all of these things. And incrementally, I can add it to the pipeline as I go along, right? And if I want to start everything off from scratch, that's totally fine too, because I can do a full refresh. So now you see, even though I have only the orders data here, DLT knows that there are 3 notebooks now, not just one notebook it has to refer. So if we do a full refresh, actually, let's do a start to show you the example. Waiting for resources should go really fast. See, now it didn't wait for resources because our cluster was still up, and it went straight to initializing. It failed in setting up tables because I think there is an error in the tables, and that is by default. So if I go back to the SQL pipelines, it's here. This is correct. Live. This should be live, I think. This is again just to show you how the syntax works. If you find time, we'll look at it. Let's see if that was the error. But this is how you would develop, right? And we're trying to show you a real world example of the errors you would run into as you develop, and how you would have to switch back and forth between between the notebook and between the pipeline. So you still need these 2 windows open. There are some plans on some improvements on this regard in which you can like sort of run it automatically. Status silver was not. So let's see, status silver is a streaming table. Okay, so this should be stream. Because this is a streaming table, I want to read this as a stream. Let's see if that fixes it. But again, we could just to show you the experience of how you develop in DLT. Now, if you get stuck at any point, note that if you go back to your main folder, there is a solutions tab here. So you could just go to the solutions tab and look at all the answers, like if you run into any code. So anytime you see like a lab exercise, there will be a solutions folder. And just in the interest of time, what I'm going to do is I'm going to copy it over from there, because I don't want to live debug in the session today. So this is what I need. So I'm going to go in here and I'm going to go back to my DLT, go back to SQL status and just put it in here, right? So the easier exercise obviously would be to just run the solutions one, but let's see if this works, right? But yeah, this is what developers are using DLT for today, right? They are writing code, running the pipeline, iterating through it as they fix errors, run the pipeline, and then keep going with it. And now you see, like once we solved those errors, the DAG was completely solved. It redrew the DAG for all the dependencies that are part of this notebook, and it's funneling everything through this pipeline. And based on, it will queue what needs to be queued and run the pipeline. So this is great. Now this shows you how DLT works. But let's say I wanted to refresh the entire pipeline. I could say full refresh all. So full refresh all is going to go all the way back to the source. By the source, I mean if it's reading from cloud files, if everything is there, it's still going to read all of it through and refresh all of these tables sort of in entirety. And our data sol is small, so we can do this. And let's say it will recompute incremental tables from scratch. What does that mean? By typically in a streaming application, you are going to do append only transactions and just propagate the incremental updates through. Now we're saying, oh, I made some code change. I made some logic change that requires me to run this whole pipeline again. So you could do this. But what if it's another scenario that says, oh, I only changed the logic for the last part. I only changed logic for email updates, right? So maybe there was some code here that joined this view and this table, and I only changed that. So why should I refresh the whole thing? Well, I don't need to. What you would do is you would say select tables for refresh, and you would pick email updates and say refresh selection. And now, again, it's going to go through all of these steps really fast because our cluster is still up. We're still in development mode. And when you see the graph the next time, it will tell you that all of the other tables are not required to be refreshed, right? If I zoom in here, it'll say excluded. What does that mean? It means we only requested this email updates to be refreshed fully. So why should I run the rest of the DAG? And this is like a really, really cool feature to have, because now you could say, I want to only update these tables. I don't want to change anything else because I changed some logic here, but why do I care about running my entire pipeline? No, but my entire pipeline is still the same, but I can choose to run part of it, right? Which is a really cool, cool feature to have. Okay, so that's your pipeline. You see all of these event logs. We're going to spend some time just exploring these event logs and exploring the pipeline results. So if you could jump to 4.3 and go to pipeline results and run the classroom setup again. We're going to show you what are the tables that DLT created for you, right? And how does it operate on those tables? When we created the pipeline, you'll notice we gave a target schema. So if you go to the settings, we gave this target, right? Which says this is the database in which I want to register these tables. That's what you're saying. So it's a table in the Hive meta store. In future, it'll be a table in Unity Catalog as well. I mean, a schema in Unity Catalog as well. But for now, it's a schema, right? It's a schema in which you're going to register all of your tables. Now, when we ran this setup notebook here, it says, okay, these are all the tables that it could detect as part of the pipeline that we created. And now we can query it just like any other tables. So even though a DLT table is, it's considered a live table, all that live means is it's within the management of the DLT engine, right? So when you're within the context of DLT, you refer to that table as live.table. But from anywhere outside, you can just say schema.table, right? So live is sort of, think of that as a virtual keyword that is required to tell the pipeline that you're referencing a table that is managed by the pipeline. That's all live is. And that's what Delta Live Tables means. It essentially means managing all of these Delta tables from within a pipeline. Do you want me to manage this table within this pipeline? Yes. Okay, then it's a live table. That's all it is. So like if you use the schema name, which is propagated here, and show tables, these are all the tables that are created, right? There's a bunch of tables created here. This one will look interesting. The apply changes. We'll take a moment to just look at that. Now you can query any of those tables, right? Just like how you would query any other table in Databricks. You would query any of those tables and it's going to give you the content of that table, whatever it was. Right. So even though orders bronze is a streaming live table, right? Because if you saw syntax, we said create streaming live table for everything else. When you query it, Delta is always going to give you back the latest results of that query of the latest version of that table anyway. So it doesn't really matter. Let's talk about apply changes into. Apply changes into is a really cool concept. So this is the customer's silver table that was created as part of this pipeline. And you'll notice it has a bunch of fields. But actually, it is a view that is created on top of another table called apply changes customer silver, right? So this is actually a view. And you can verify this by going back to your DAG and looking at the DAG. And you'll see customer silver is actually a view. It says table, but it is actually a managed view on top of the table. So anyway, so what is the difference between this apply changes and the actual table that consumers are supposed to query, right? You want to give customer silver to all of your downstream consumers. You don't want to give them the underlying table, but the underlying table is what is using the logic from this underlying table to populate the view. Why does it do that? It does that because there are a few additional fields that are created as part of apply changes, which is timestamp and upsert version. And this won't really make sense till we actually look at the customer's pipeline. But let's look at the code quickly. Silver. Right. So this is the interesting syntax that you need to pay attention to. It says apply changes into. And apply changes into essentially is creating a slowly changing dimension table, right? If you're familiar with slowly changing dimensions, and if you look at our sort of product difference that I showed you earlier with this product link, this slowly changing dimension is SCD type 1 or type 2 are built into Delta Live tables. You don't need to say SCD type 1. Delta Live tables automatically understands that you're trying to create an SCD type 1 table, which basically overrides records. But you could also create an SCD type 2 table, which maintains history, right? So which let's say if an address changes, you want to keep the older version of the address, but create a new version with the old version having an expiry date. That's an SCD type 2. Delta Live tables can do that automatically for you with just one line of syntax. What you would do is at the end of this, you would say stored as SCD type 2. We don't need to say that here because if you don't mention it, we default to SCD type 1. What's really happening is because this is an apply changes table, Delta Live tables creates an underlying table that captures the changes to that table. and then exposes a view on top of that for consumers to see. So customer silver is what you said the table should be. Delta live tables automatically created a table underneath that said with the underscore word, which is basically this apply changes table, right? So it manages it automatically, and you didn't have to say anything. You just had to say apply changes, and DLT understood it's an SCD type 1. And if you say apply changes stored as SCD type 2, you would create a type 2 table. And again, it would create an underlying table that has all this logic on all of the expirations and all that stuff, and create a consumer facing table on top of it, right? So it's really, really powerful, and makes the like creating these kind of data patterns of SCD, slowly changing dimensions and change data capture and all that, which is very, very difficult to do in a traditional data lake. And it makes that really one line code, right? I mean, it's like so simple. So if you look at what happened here at the cloud storage location, when we looked at our Delta table, you saw there were a bunch of Parquet files and there was a Delta underscore log, right? Now, what DLT is doing is it's creating a bunch of other folders. Again, all of this is managed under the hood for you. You did not create any checkpoint. You did not define where to store the checkpoint. You did not specifically say, create any of these folders. The autoloader folder was created because we use the concept of cloud files, which is an autoloader, how you read here. So when we created the first customer's bronze table, we use cloud files. So cloud files is how you interact with autoloader. So DLT automatically works with, autoloader out of the box. So it created an autoloader stream. It created the checkpoints needed for that autoloader stream, and it is managing all of that for you without you having to specify even a location. If you're curious, it just stores it under the system tables to see which locations it is tracking. But all of this is created for you on the fly, right? So there's the tables, which are the actual DLT tables it's creating. There is the checkpoints, which is how it's maintaining the state of the streaming application itself. Autoloader, which is keeping track of the cloud files that it's ingesting for each table into the raw layer. And then system, which is a bunch of system tables that we will look at right now, which is here. So if you query, and the interesting thing is all of these paths, obviously you can traverse to all of these paths, but by default, DLT is creating all of the tables under this as Delta tables, right? So it's stored as Parquet with a Delta log, everything, which means you can just create a table on top of these and like create operational dashboards on top of it, create a Databricks SQL dashboard on top of it to monitor it and do all of these things. So this is the system events table, and you'll notice it's basically a Delta table. The events table is a Delta table, and that is what is being populated here. So all of these things you're seeing here is basically rows from a Delta table that is being created by DLT to manage the events for that pipeline. Again, you can query it very simply like this. Select star from path. You can see a delta.path. It says it's a Delta table, and you can query it. And if you scroll through here, you will see exactly sort of the same, messages. Flow is starting, flow is running, as you're seeing here, right? It's the same thing. You can query each of the tables themselves directly, of course. These are all the tables that DLT is managing within this pipeline. So you can see there's a bunch of orders tables, email tables, and customer tables. Okay, and then we'll show you how to actually make sense of the event logs, right? For that, we'll jump to 4.4 and just go through this notebook as well. The event log is like really, really powerful because think about your traditional structured streaming application or even a batch job that you run. It's very difficult to sort of figure out what happened when something went wrong, right? You would most likely go and look at the driver logs for that cluster. You would look at the Spark UI to see what happened. Like you're doing all of this debugging information to figure out what just happened in my workflow. And so DLT is taking all of that away from you. Don't have to worry about it. Obviously, you can still go to the Spark UI and monitor the performance of each job and task. That's totally fine. But all of this operational sort of headaches that are built on top of it add very little value and take away a lot of time. And we don't want you to be stuck doing that, right? So we're just going to show you an example of how simple it is to read. So this is the path where event logs are stored. And that is the storage location that you defined over here in the pipeline settings. You defined a storage location, which is this. And the event log is always stored /system/events. Event is basically one of the system tables. So system tables and then event, right? And here's a like PySpark way of reading the Delta table, right? Spark.read format Delta, load event log path, and then create or replace temp view. So this is a temp view now, event log. And we are going to display this. Okay, awesome. So we see some events. Now, imagine your pipeline was running, every hour you triggered it and it's running every hour. You want to know what happened in a specific update, right? So each run of this DLT pipeline will have an update ID, which you can find here. This like this. So this was the update ID for this run. Now, if I run this pipeline again, for example, it will get a new update ID, which will be this. So you can actually programmatically query the data in that event log for each update ID, right? And you can do it like this by just saying, okay, I want everything from this event log, but I want you to, sort it and give me just the first, which obviously descending first, meaning the latest, right? And I want to programmatically store it somewhere and do something with it, right? And you can even go back and set that as a Spark conf and then refer to it in some other downstream job that maybe you want to check some statistics about this event. But you essentially you can retrieve this information from the event log, set it as a Spark conf to actually then do other things that you may be interested to do with this, with analyzing that specific flow, right? What else can you do? Well, it comes with audit logging out of the box. If you notice at our Delta, in our described history of Delta, it will tell you that it created a table. It was from a specific notebook and a specific operation or whatever. This is a very similar concept, except it's telling you for each pipeline, who started this pipeline or who did what for this pipeline. Now, in this case, this is filtered for whatever I did because this is just my workspace. But you can see if I sort by this, I created it, I started it, I edited it, I then started it multiple times. So I can walk through this. And then if you're in a shared environment, obviously the usernames here will be different. And then you can say, oh, who started the last pipeline? Now, in a production system, you can run the DLT pipeline as a service principal, so it doesn't really matter. But during development, it's sort of helpful to see who's doing what in your pipeline. And this UI that the DLT shows for lineage, right? So if you click custom accounts, you can see, oh, it's coming from, this is a table, it's this is the name of the table, and you can visually look at the DAG and say, oh, silver is, it's reading from silver, right? But how do you programmatically check? Well, you can do it by just querying the event log with these filters and for the latest update ID or for all update IDs. And you can say, okay, what is the lineage, right? So if I sort by this, status bronze, orders bronze, and customers bronze has no input data sets because it read directly from cloud files. But all of the other ones have. So for example, email updates, sources from 2 tables, right? We can check that here, email updates, sources from 2 tables. So it's really giving you that visual interpretation of your pipeline, but it's also giving you a programmatic way in which you can inspect and figure out, right? So if somebody tells you tomorrow, tell me all of the tables that are affected if I make a change in status silver. Well, you can do that easily because now you have information in that pipeline, right? You can also programmatically check all the data quality insights. So if you click on each of these tables, well, my last update did not have anything. So I'm going to run it a full refresh again. But you'll see like a DQ stat for each table, which you can see in the UI, but you can also query it programmatically from here, right? And there's some code given here. Again, all of it is coming from the event log raw. So that's your raw data, and then you basically add code to pass through it, which DLT is doing for you in the UI as well. This came back because I'm still running the refresh. So once the refresh completes, it should come back. One general question we have heard a lot from customers is, what is the difference between a Databricks workflow and a Delta Life Tables pipeline, right? And they serve two slightly different purposes. When I think of Delta Life Tables pipeline, I'm thinking of all of the Delta tables that I want to populate to satisfy a specific use case or project or something like that, right? So if I have an application that requires data from 10 sources and I need to do a bunch of logic to finally prepare a table for that application, I'm thinking I should put all of this in one DLT pipeline because these are all related and they all need to be in one pipeline. When would you create different pipelines? You would create different pipelines when you don't have like strict dependencies between one table and the other, and they have different relationships with other tables and things like that. So once it gets a little more complicated, you can split it into different pipelines. But in general, you can add a lot of tables to one pipeline, and DLT is going to scale up to handle it the best it can. Let's see if this comes back. Yeah, this didn't come back. So anyway, it would have come back. I did something wrong. Workflows is how you orchestrate everything in Databricks, including DLT. So if I go to this workflow that I created before the session, I have, if I go to the task, I have a job, a normal Databricks job, a notebook job, but I also have a pipeline. So you can think of it as, if I have some pre-steps to check before I run my DLT pipeline, I'll put that in a notebook and I'll schedule that as a job. And if I have some post steps, because DLT can only write out to Delta tables today, but I want to export this data out and send it to an external system like Redshift or something like that. Well, that would be a post step here where I have another notebook that does that export out, right? So DLT is for managing the end-to-end pipeline of all the tables that you want to think of as your core data engineering pipeline. Everything else fits around it using workflows, right? And you can schedule the whole thing. You can schedule this whole workflow from here, right? Which will also run the DLT pipeline. But if you don't want to do that, and if you want to run the DLT pipeline by itself outside of the workflow as well, you can still do that because you can come in here and schedule the pipeline separately as well. So they go hand in hand. They sort of serve slightly different purposes. DLT is for orchestration of your core data engineering pipelines in Databricks for Delta tables, and workflows are for you to run pretty much anything in Databricks, but build those dependencies to other things, right? So if I was to create a new task here, I have a plethora of options, like all of this stuff. I have a standalone Spark Submit job I want to run right after the DLT pipeline. Well, I can do it. I have a SQL task. I want to go and run a SQL query in Databricks SQL. I can do that. I can refresh my Databricks SQL dashboard right after the DLT pipeline by giving it as a dependency to the stack, right? So workflows is for orchestration of everything across Databricks. You can even call like standalone Python scripts like us that does something outside of Databricks if you want to. So the entire orchestration is through workflows, and the core management of all Delta Live tables or Delta tables should be through Delta Live tables, for which you would create a pipeline, which is part of a workflow, or it could exist on its own. So you have both options. I think we're at 1:24, so pretty close to the time. So I'll kind of stop here. Nadia, do you need 5 minutes or?
Just 2 minutes. So if you have a couple things, you can keep going if you'd like.
Awesome. Okay, so if if you want to try to run any of this yourself, right? Obviously, you have access to the code through the GitHub repo or through just exporting it from here. I think these workspaces will be taken down after the session. So right now, if you want to export it to your local, you can do it and store it for later use. If you are preparing for the data engineering certification, right, both of these sections that we covered today, 3 and 4, are applicable to it, whether you write the V2 or the V3. I would definitely play around with O2, which has some interesting labs using PySpark and how to write SQL UDFs and Python UDFs, which is important for the data certification examination. I would also look at managing permissions, because one of the things that if you're writing the V3 is you want to be able to understand the concepts in Unity Catalog and how you govern your access to metastores not so much, but catalogs, schemas, tables, functions, things of that nature, right? If I create a function, who should I give access to? What access should I give them? If I create a table, how can I give them somebody else access to it? Things of that nature will be asked in the data engineering certification. So it's good to, so this whole section about managing permissions is useful for that. If you have not a lot of background in PySpark by itself, because there will be a few questions about PySpark in the certification, I would say, definitely go through this intro, which is 00, and the optional PySpark, right? Because that's going to give you a better understanding of some of the nitty-gritty of the actual code questions that may come. Again, it's not very complex questions, but you need to be really familiar with the syntax. That's it. So once you're familiar with the syntax, it becomes easy. I didn't really get time to cover this, but in the Delta Lake section, which we did, we started 3.2. But if you go to 3.1, it has a very useful overview of what managed and unmanaged tables are. And I think you can read about it in our docs, but it has some very interesting notebooks that tell you what happens when you drop table for a managed table and drop table for an unmanaged table, which I think would be useful for anybody to understand, because those concepts hold true today with your regular Hive Metastore and how Databricks works, and it also holds true tomorrow when you move on to Unity Catalog. Yeah, and one last thing, if you get stuck doing any of these, if you see an L at the end of it, that's a lab, which means you have to complete the code if you're doing it. And if you get stuck there, just flip over to the solutions, go to the corresponding 3.3L in the solutions, and you'll find the answers to that. And I highly recommend that you just work through all the notebooks once before you attempt the certification, because it's giving you it'll give you that sort of recall ability at the exam. And I think with that, we can stop.
All right. Thank you, Mahan. Can you hear me?
Yes.
Okay. All right. Thank you, everyone, for joining us today. We hope you've enjoyed day 1 of our foundational training series. We hope to see you at tomorrow and Thursday session as well. Just a couple of reminders. You will receive a thank you email later today that will point you to the resources shared from today. Be sure to complete the survey and the accreditation by December 22nd. You can find it in the thank you email that I will be sending. You will need to show proof of the Databricks Lake Fundamentals Accreditation version 2 in the survey, and you can expect to receive the voucher from our team before the end of January. It'll be valued at $150, which is 75% off, for you to take any of the exams before June 1st, 2023. Amazing job, Mohan, and the whole team of TAs who have been answering your questions. We really appreciate all the users who have joined us today and hope you have a great day wherever you are based, and see you at our future events. All right, thank you, everyone. Bye.